It's not December, but okay. Yes, thank you. I didn't know how to make that into 11/20. Okay, you said 7.2, so let's take a look. And the problem is
11.
Problem 11. So this is 11. We have m plus n everything squared divided by m minus n and multiplied by m over m squared plus mn. Perfect. Since it has two variables, we assume all conditions are fulfilled. We don't have to write restrictions. So now, this is completely factored, this is completely factored, this is completely factored. There is nothing else I can do there. But this is not. So what could I do to the second denominator? Yes, factor out an m. Assuming all conditions are fulfilled, I will simplify. An m from the top with an m from the denominator. An m plus n from the bottom with an m plus n from the top. What is left as the simplified form of this expression? Now, I'm tempted to simplify this m with this m and this n with this n and get something. No. Why? Because m and n are not factors, they are terms. M and n are not factors, they are terms. Yes. And that's it. Very good. Becky, is this okay? Okay. Next problem.
13.
Same page?
Yes.
Okay. So for 13, we have x squared minus 25 divided by x squared minus 3x minus 10 times x plus 2 divided by x. I need to completely factor everything. Well, I cannot do anything to this, and I cannot do anything to this. But I have to factor x squared minus 25. And since I only have one variable, I will state restrictions. So how do I factor x squared minus 25?
X minus 5, x plus 5.
I'm glad you're back from vacation. And the denominator now, please. Physically and mentally. That's what I meant. Because you can be present, but still think of a beach or something.
X minus 5 and plus 2.
So we see three different factors, correct, in the denominator. So we will have three different restrictions. And only then we can simplify. And I caution you that the book does not do this. And this is very important. And you will see it will carry over into chapter 12 in a minute. So
5.
good. Now I'm free to simplify. An x minus 5 with an x minus 5. You cannot simplify bottom with bottom and top with top. It has to be one from the top, one from the bottom, even if it's from a different fraction. And then the simplified form of this is, good. Can I simplify x with x? No. So the correct answer is this. Very good. Is there anything else?
19.
Same page?
Yes, I was kind of confused about this. Where you multiply
Yeah, let's take a look. It's better to start from scratch. it's easier to find a mistake if we start from scratch. You said 19, same page, right?
Yes.
19. Okay, I got it. And this is 8. X squared divided by y cubed. And further divided by 4, x squared y to the third divided by 6. Good. We cannot simplify across in a division. So for now, what I recommend I do is write y does not, they're two variables anyway, so I started. So y cannot be 0. The only thing I can do, nothing here, the only thing I can do here is simplify by 2. I am allowed, because I'm simplifying the fraction, not across in a division. You don't have to, you can wait till you change it into a product. It's not going to make any difference. So then I have 8x squared over y cubed, and multiplied by 3 divided by 2 x squared y cubed. Okay, of course, x is, since I started, I have to write both of them now. So the only thing I can do is two things, actually. I simplify x squared with x squared, and I get a 1. And I simplify 2 by 2 and 8 by 2. The numerator only has 14, right? And the denominator has y to the 6th. This y times this y. And there is nothing else. Copy the base and the exponents. I'm sorry? Oh, I don't know. You can't dispute what a professor tells you. 3 times 4 is 14. I'm sorry. Sorry. No reason. 4 times 3 is still 12. Yes, Becky, I'm sorry. I confused you with the 14. I'm sorry. Sorry. Is this okay? Okay, anything else?
23.
23. Same page?
Yes.
Okay, so for 23, we have 3x squared over x squared minus 1 divided by x to the 5th over x plus 1 squared. Okay, so I will factor the denominator into x plus 1, x minus 1, and then x to the 5th and x plus 1 squared. At this stage, I will write two restrictions. X does not equal plus or minus 1. There is nothing I can do. I'm ready to flip the second fraction. So 3x squared over x plus 1, x minus 1 multiplied by x plus 1 squared divided by x to the 5th. So I have an additional denominator that I did not have before, so I'm adding one more restriction to the list. And now I'm ready to simplify. 1 from x plus 1, an x plus 1 from the denominator goes away with an x plus 1 from the top. 2x squared, 2 of x with 2 from here go away. So the top is 3 multiplied by x plus 1, and the denominator is, I put x cubed in front times x minus 1. There is no need to distribute the factors in the denominator. There is no need to do that. Okay, it's uploaded. Any questions? Becky, is this okay?
Yes.
Is there anything else we need to look at?
37.
Same page?
Yes.
Very good. So let's look at 37. 37. I see it. 3x plus 4y divided by x squared plus 4xy plus 4y squared, and multiplied by x plus 2y over 2. Let's assume that everything is not 0 in the denominator. So then the numerator of this fraction cannot be factored, but its denominator can. So 3x plus 4y over, and times x plus 2y over 2. Can anyone give us the factored form for this? And I'm going to give you only one hint. We discussed this from the first time this semester, the first lesson we had this semester. We have an agreement on it. Say it again. Can anyone give us the factored form of this denominator?
Would it be 3 times?
Yes?
Okay, and then so x plus y, and then x plus y and y plus y.
It's a perfect square.
X plus 2y.
Exactly.
Oh,
Right. So remember, when we have a trinomial, always go through all the steps. In descending order, greatest common factor, negative leading coefficient, special product. We always really hope for a special product because that's the easiest. So it is a special product, which is x plus 2y, everything squared. Assuming all conditions are fulfilled, the only thing I can do is this. 1 from the top with 1 from the bottom. So 3x plus 4y, I put 2 in front, 2x plus 2y. Do not distribute the factors in the denominator. Ready? Is there anything else, Becky?
41.
Same page?
Yeah.
41. So we have x squared minus 4 over 24x divided by 2 minus x over 6xy. First step. We have to factor the top. How? Excellent. There are two variables. We assume everything, all conditions are fulfilled. So I change it into 6xy divided by, however, I don't like 2 minus x. It's not in descending order, and it has a negative leading coefficient. So I will be factoring out negative x minus 2. So there is a negative 1 in front. Any questions? Any questions? So now we're ready to simplify, assuming we stated all restrictions. So an x minus 2 with an x minus 2, an x with an x, a 6, and a 4. The simplified form has to have a minus in front because of this negative. What is left at the top? And a y. So I will put the y in front. What is left in the denominator? Just 4. But I put a negative in front. Good. Anything else? 7.3, very good. This is a very good review for Jackie as well. You never told us it was a boy or a girl. Wonderful. Congratulations. Yes, 7.3. 17. Very good. On page 466. Two x squared divided by x minus 5 minus 25 plus x squared divided by x minus 5. The only restriction we have to state here is just x not equal 5. Good. When we add and subtract, we never factor the numerators, but we have to factor the denominators. But there is nothing to factor. There is only one denominator. It's the same. All I have to do is perform the calculations at the top. So 2x squared minus 25 and minus x squared. Remember, the negative sign gets distributed as if it's in front of a grouping symbol. So now 2x squared minus x squared will be x squared minus 25 over x minus 5. At this last step, I have to try to factor the numerator because there is nothing else. I only have one fraction. And how does the numerator factor? X plus 5, x minus 5. We already stated the necessary condition or restriction. Now I'm ready to simplify. 1 at the bottom, 1 at the top. Remember, if you don't write 1, you may think it's 0. So what is the simplified form of this expression, assuming that x is never 5? X plus 5. Very good.
Nineteen.
19. So 5x plus 4. Can you try 19? Is the same way. Is it clear now what to do with 19? If you want, we can still do it. Should we? Okay, let's do it. Let's do 19. 5x plus 4 over x minus 1 minus 2x plus 7 over x minus 1. So the same restriction here in the sense that just one denominator, so x cannot be, right? And then all I have to do is just copy the denominator and carefully perform the operations at the top by simply distributing -1. So 5x plus 4 minus 2x and minus 7. Remember, the negative sign gets distributed to all terms. So then 3x minus 3 divided by x minus 1. Now I have to attempt or try to factor the numerator. And that would be, so 3x minus 1 over x minus 1. We stated the restriction, so now it's safe. So the answer is 3. Yes, at the very end, after we add and subtract, we have to try. If it's not factorable, it's not factorable. Same page? Okay. Let's look at 36. In 36, we are only asked to find the least common denominator. So let's find it. So we are given two expressions, 4 divided by x squared plus 4x plus 3. We're not asked to do anything, just find the least common denominator. So we have to completely factor each denominator. So 4 divided by x squared plus 4x plus 3, and 4x minus 2 divided by x squared plus 10x plus 21. So we're going to try to factor both denominators and see what we come up with. Do we have the factor form for the first one?
X plus 1 plus 3.
Perfect. Do we have the factor form for the second one? So the LCD has to have all different factors written only once, or written to their highest power, but not adding powers. So can anyone dictate the least common denominator? Not the greatest common factor, but the least common multiple, or the least common denominator. All different factors have to be in the least common denominator. All of them.
X plus 1 plus 3 and X plus 1.
Excellent. Very good. Anything else?
7.4.
7.4. Moving on. Excellent. Yes. Which problem?
Number 7.
Number 7. In number 7, we have 6 over x plus 1 plus 10 over 2x plus 2. Good example. First thing we need to do is, say it again. I have to factor completely, each and every one of them. So 2x plus 2 can be rewritten as 2 times x plus 1. All different factors have to be in the least common denominator, and x cannot be negative 1. That's the only restriction. So what do I write? What is the least common denominator then? Say it again. Times all different factors. 2 times x plus 1. Very good. The first one needs an adjustment. What will you write at the top? 2 indeed. And this one doesn't need anything. By anything, we mean 1. So 2 times 6 is 12. 12 plus 10. And that will give us 22. And we get 22 over 2 times x plus 1. And if I can, I have to simplify. And I can by 2. So the simplified form is this, assuming x is never negative 1. Perfect. Good review. Anything else?
37.
37. Good. So in 37, we have 2x over x minus 7 minus x over x minus 2. You will give 2 restrictions, right? And they are 2 and 7, indeed. And then we'll have to find the least common denominator. All different factors have to be in the LCD. And they are That's the product. So then the top of the first function, I'm sorry, fraction, needs what? Right, what it does not have. And the top of the second one needs, perfect. Now carefully, let's write the top. Can anyone dictate?
2x squared
Very good, 2x squared
minus 4x
minus 4x.
minus x squared
Excellent.
plus 7x.
Wonderful. Excellent, thank you. So now we combine like terms. Is this okay? We combine like terms and we have x squared plus 3x divided by x minus 7 times x minus 2. Yes, I could factor out an x at the top. I can do it, but it's not going to help. I will not be able to further simplify this. Good. Anything else? Other questions?
I don't want to
Awesome. You made a lot of progress. So I'm hoping that this weekend you finish up 7.4, 7.5, 7.6, and 7.7. Awesome. Good. So anything else for me from chapter 7? And now we are ready to start chapter 12. Anything else? Anyone? Okay. Let's see. I would like to list the major topics in chapter 12. There are mainly 4 major topics. First one, algebra of functions. Next one, function composition. Next one, inverse functions. So algebra of functions, function composition, inverse functions, exponential function, and the last one I'm adding one topic because they are together in the same section. For example, these two are together. A logarithmic function. These are the major topics. Then I could add solving exponential equations, logarithmic equations, and word problems, and so on and so forth, but they are all included. So we're going to start with algebra of functions, and then function composition. Okay. And this is 12.1. Let's suppose we have 2 stores, one in Annapolis and one in Baltimore. And let's suppose we have a profit function that will give us the profit in Annapolis and another profit function that will give us the profit in Baltimore. But we are one company and we would like to have a total profit. How will I determine a function that will give us the total profit? I will add the function that gives us the profit in Annapolis to another function that gives us the profit in Baltimore. And we will get a function that is called the total profit of this business. That's a simple example. What algebra function deals with. What does it deal with? Addition, subtraction, multiplication, and division of functions. That's the algebra of functions. Okay. Now, if I say to you, let's find the function t of x. Don't write this. I'm just showing the idea. So I'm asking you, let's find function t of x. What will you say? How? No, you're asking me to find a function, but you're not giving me any information, and you haven't told me how to find it. But if I say to you, given f of x and g of x as two functions, and I'm asking you to find f plus g of x, you will definitely know what I'm asking you to do. If I ask you t of x, you're going to say, I have no idea. You have to give me information. But here I don't have to give you information. If I'm asking you to find this new function f plus g of x, you will know exactly what I'm asking you to do. What will you do? How will you determine this function? Exactly. You will add f of x to g of x. This is the first function that we can create if we are given two functions. If I'm given f and g, now you can write this. I just didn't want you to write that. So if I'm given f and g, and I'm told find f plus g of x, I don't need more information. It's self-explanatory. So given f and g as two functions, this must be the sum. So this is the sum of those two. Okay. Again, it's self-explanatory if I ask you to find f minus g of x. You will not ask for any more information from me. You will say, I know. So what will that mean? That's it. So this is the difference. Again, with the fg of x, you will not ask for more information because you will know how to create fg. How will you create fg? That's it. So this is the product of these two functions. And the last one in algebra of functions. Again, you will not ask for any info. If I ask, please find f over g of x. You will know what to do with no additional info. You will say f of x over g of x, but we studied this now in chapter 7, comma, if. I didn't need a comma and if for the other three, but here I have no choice. There is an if. Why there is an if here and I didn't have it before? Right. Before we look at an example in which we will create these functions, I just want to talk about a potential problem. Here's the potential problem. In an expression or in a function, x cannot take two values at the same time, right? So, for example, if this is 5, then this is 5, and this is 5. If this is negative 10, this is negative 10, and this is negative 10, right? So both functions have to exist at 5 to create this. Both functions have to exist at negative 10 to create this. So for example, if I have function f here, and let's say I have function g here, I cannot create any of those functions. Why? Because if I ask you find f plus g at 0, you will say this is f of 0 plus g of 0. You will measure this and you will say, I don't know, it's 5. But you cannot determine this because g is not defined at 0. So this is the concept of common domain. If these two functions don't have a common domain, the sum, the difference, product, and ratio cannot be created. They don't exist. So, yes. So the common domain is required when we add, subtract, multiply, and divide. functions. So if there is no common domain, I cannot create a sum, difference, product, and ratio. So I think we should start with an example, like on page 717. 717, let's say problem 3. Sure. Problem 3 on page 717. We have f of x equals x squared plus 1, and we have g of x, which is 5x. In this problem, we are asked to find the sum, the difference, product, and ratio, and their domain. Okay, so first I will find the domain of this function, which is the domain of f. Then I will find the domain of g. Let's identify the function first. It's x squared plus 1. We know this from chapter 9. No, from chapter 11, sorry. That this is what type of function? Quadratic. So if I want to graph it, it will have a minimum, right? This is x squared and plus 1. What is the domain of this function? All real numbers. Now let's look at g. I know what this function is. What type of function is 5x? Right. Does it look like this? With a positive leading leading coefficient or positive slope? Good. So then what is its domain? Of course. All polynomial functions have domain, all real numbers. So what is the common domain then? Where both functions exist at the same time. Exactly. This will always be the domain of the sum, the domain of the difference, and the domain of the product. Notice that I have not mentioned anything about the ratio. I don't know. I can conclude before I look at it. But I can immediately conclude about the sum, difference, and product. But I cannot conclude about the ratio yet. Good. So let's find them. So I don't have to mention the domain of those three functions, but I will have to determine the domain of the ratio. Okay. So f plus g. Please always write the definition so I can see. In case you make a mistake, then I know you know what you're talking about. So this is x squared plus 1 plus 5x. Yes, I will arrange it in descending order, and this will be x squared plus 5x plus 1, and it's done. Is it clear why the domain is all real numbers? It's a quadratic function. Okay, f minus g. Same thing. Definition is f of x minus g of x. So then I have x squared plus 1 minus 5x this time. I arrange it in descending order. X squared minus 5x plus 1, and it's done. It's a lot of writing in this section because of these functions that we create. Okay, next one is the product. The definition is f of x multiplied by g of x. So then f of x, which is x squared plus 1, multiplied by 5x. I have to distribute. And I get 5x cubed plus 5x. And it's done. There's nothing else. So I determine the common domain by finding the domain of both and see where they overlap. They overlapped everywhere this time. Okay. Then I determine the sum, the difference, and the product, and I know that they have the same domain with a common domain. But now I'm ready to find the quotient. So let's find the quotient. F over g of x is f of x over g of x, and f is x squared plus 1 over 5x. I cannot simplify anything, but I have to write if. If what? Bless you. If what? You may have said it, I didn't hear it. I'm sorry. Excellent. So now I'm also asked to find the domain of this function. So let's find the domain of this function. Obviously, x cannot be 0, but now I'm ready to find the domain. So the domain of the ratio. And that is, how do we write it? That's it. In other words, in plain English, everything but 0. Excellent. So this is how we determine the sum, the difference, the product, and the ratio of two functions. And please remember the concept of common domain. So let me give you just a quick example. Let's suppose I have this function, the square root of x plus 1 plus the square root of x minus 3. Does this resemble anything? Yeah, it's a sum of two functions. This is one function, and this is the other. How do I determine the domain of this? Well, it's the common domain. This exists if this piece, if this function and this function have a common domain. If this one is defined to the left of 1 and this one is defined to the right of -3, this function doesn't exist. So let's see. Let's find its domain. What condition will you write for this one? You will write that x plus 1 must be. Excellent. What is the condition for this one? That x minus 3 must be. Very good. So now I solve this to get greater than or equal to -1. I solve this to get greater than or equal to 3. And now I will look at the real line, graph the first one, -1 to 3, to infinity. You know I don't care for units. I just need this to help me find the domain, the common domain. And this one is 3 to infinity. So what would be the domain of function f? Yes, because if purple and red don't have a common territory, f doesn't exist. So yes, the domain of f is indeed the common where I see both red and purple. So it's indeed 3 comma infinity. Now if I had changed this into x plus 3, let me write it. I don't want to change it there. I just want to show you what happens when, we don't have to do this again, but if this one goes this way and the other goes this way, there's no common domain. The function will not exist. It's not this case. I have to think for a second before I write it. But if this is the situation, then the domain does not exist. This function has no domain because these two never overlap. The domains of these two never overlap, and then this function cannot be created. It's a function that I cannot plug in any x. Who cares about it? No one. Okay? So that is the concept of common domain. Now, the next step is what is called function composition. What does that mean? Well, it's the fifth way of creating new functions. We know 4. We know the sum, difference, product, and ratio. This is the fifth way. And you can say, do I really need the fifth way? Isn't that enough? It is, however, almost everything we have, almost all functions are function compositions. In other words, the functions, yes, sum, addition, multiplication, subtraction, and division exist. But almost all functions are determined by plugging in a function, another function. So let me discuss that. So what is the notation? F, a circle G of X. How do I read this? The long way is the composite of f of x and g of x. Too long. The short way is f comp g. F comp g. In other words, the composite of f and g. Okay? Now, can I do it the other way around? Yes. G comp f. Can I create the function composition of f with itself? Yes. Can I create the function, the composite of g and g? Yes. And I can go on forever. We're mainly interested in these 4 possibilities. But what is it? I don't even know what it is. Yeah, that's a fancy notation, but what does it mean? Here's what it means. Let's suppose I have x here. G is the closest function to x. That's why this will be called the inner function. The next function I apply to g of x, you'll see in a moment, is called the outer, assuming we only have 2. So here's the mechanism. I apply g to x. So this is x. I apply function g to it, and I get g of x. When I apply a function to a variable or to a number, I get g of that number. If this is 5, then I get g of 5. If this is 0, then I get g of 0. But now I will be applying f, function f, to this new number I just determined. I apply f, and I get f of g of x. And this is what the function composition is. So f comp g, this fancy notation, f comp g of x, is f of g of x. How will I determine g comp f? Can anyone give us the definition of g comp f of x? So one more time, let's write how we read this. F of g of x. So what about g comp f? G of f of x. What about f comp f? What will that equal to? F of x. What about g comp g? G of g of x. Excellent. Now, what could go wrong here? There is no need for the concept of common domain. That's a totally different story. What can go wrong here has nothing to do with a common domain. I can create the function composition regardless of a common domain. But here's what could be the problem. What does this set represent? And I'm not going to ask you to determine this. This is not a concept for this class. So what does this the set represent for function g, where I pick x values from? What will this set be for G? What is the set of values of X? Domain. What is this set for function G? Where the Y values are coming from. Right? It's the range. Perfect for G. Okay, now, what is this for F? Domain. So if the range of G and the domain of F do not work well together, I could never get here. The chain could be broken. Here's an example. I apply G to a number and I get 0. But F is not defined at 0. I can continue. I will never get here. So here the potential problem is that the range of the first function I apply, the range of the inner function, doesn't work well with the domain of the outer function. But this is not a concept for this class. I'm not going to ask you to find the domain of the function composition. Okay? But this is what could go wrong. Okay, so we already have two functions. Let's go back to the same thing. We had, what was it, x squared plus 1 and then 5x, right? Is that correct? So we have f of x, yes, Becky? X squared plus 1 and g of x, I think it was 5x. I would like to find those four functions. F comp f, g comp g, f comp g, g comp f. Ready? So f comp g of x. Please write the definition first so you don't make a mistake. So this is f of g of x, which is f of 5x. Now I look at f. What does f say? F says whatever squared and then plus 1. How do I write this? That whatever squared and then plus 1. Very good. Squared and then plus 1. Excellent. How do I square 5x? It's a product. There is no problem there. It's not a binomial. So that is 25x squared plus 1. Now let's look at f comp f of x. First the definition, please. What do I write? F of x. Now careful. I plug in here. I replace f of x by what? Very good. Now I go back to f. Again, f says whatever squared and then plus 1. How do I write that? Plus 1. Remember, we have an agreement. This is a binomial squared. What do I write next? How many terms? The first term squared plus 2 times the first times the second plus the second term squared, which is 1, plus 1 is 2. Let's find the g comp f. Any questions from me, please? Yes, Becky, go ahead. Yes. Plus b squared, which is 1, plus 1 is 2. Is that okay? Yes? Okay. G comp f. Definition, g of f of x, which is g of x squared plus 1. Now I look at g. G says 5 times whatever. How do I write that? 5, and in parentheses, x squared plus 1. I distribute 5x squared plus 5. Finally, g comp g. The definition first, g of x, which is g of 5x, which is, I look at g again, 5 times whatever. So that is 5 times 5x. Any questions on how to find the function composition? Function decomposition. And you could say, really? We just compose function. Now we're going backwards? Yes. Now we want to identify the inner function and the outer function. In all these problems, there is more than one correct answer. So let's give it a shot. It's a very important topic for calculus. Depending on how far you have to get in math, this is a very important topic if you need calculus. Okay, so let's say I'm looking at problem 34. On page 717, I'm given a function denoted by h of x equals 3x plus 4 squared plus 2. Yes, you can say this is a sum of two functions. I will have to agree, but it's also the function composition of two functions or more. So they're asking us to find an inner function called g and an outer function called f that will equal this when we create the function composition. So what I need to do is look at the function 3x plus 4 everything squared plus 2 and say, if I'm asked to evaluate this function 4x equals 5, what will I do first? Well, obviously I will have to do this first. Once I'm done with this and I get a number, then I square it. Once I get a number, then I'm adding 2 to it. So I already have 3 functions in there. I have 3x plus 4, which is the inner function, x squared, which is the second inner function, and blah plus 2, which is the third inner function, the third function, which is the outer function. But the problem is only asking us to identify 2. I can identify 2, you can identify 2, and both answers could be correct. 2 different functions. So please create an inner function, g of x. Of course, everything goes in order of operations, and you can stop anywhere you want. What could be the inner? Good. That's your inner. So you got one number. This is just one number now. So now give me the function that will use one number squared plus 2.
X squared.
That's it. Let's see another option, and then let's check one of these options to make sure that we get that. Say it again. Becky, go ahead. Did I do something? You want me to shut the door?
It's fine.
It's too late.
I didn't hear it, sorry. Okay, ready? So let's find another pair. Just to show that there is more than one correct answer. You could consider this the first function. 3x plus 4 everything squared. Once you get a number, what will be the outer function? X plus 2. Which one would you like to check to see that the function composition, f cum g, will definitely give us h? You want the first option or the second option?
First option.
First option. Very good. So we are going to calculate f cum g of x. By definition, this is f of g of x. or f of 3x plus 4. I look at f. F says whatever squared plus 2. So what will I write? And we showed that the choice of two functions, the inner and the outer, is perfect for creating the function composition, h of x. Let's look at another one. Let's say 36. You can come up with several, but we only need one. We want an inner and an outer. The inner is g of x, and the outer is f of x.